Today we're going to show you how PLC programming and variable frequency drives are integrated together to control an electric motor. What we have here is our PLC, and that's going to operate, pretty much tell what our variable frequency drive to do to operate the speed of this electric motor here. We got a start and stop button wired into the PLC, along with a proximity sensor sensing when a conductive material is in place in front of it. Over here we got our hydraulic circuit, what the electric motor is going to be operating, and over here is our wiring diagram for the PLC and the variable frequency drive. And Garrett here, oh homeboy Garrett, love Garrett. Garrett's going to explain to you how this, how the PLC tells the VFD what to do and spin the motor at what desired speed we want. So Garrett, how does this work?
Alright, so the PLC responds to the inputs, which are stop, start, and our inductive sensor over here. When the start button is pressed, it creates like a holding circuit telling the PLC that it's okay to start the motor. And when there's a part present in front of the inductive sensor, it contacts our analog card to let the VFD know that it should start ramping up the motor. So it'll have a 5-second idle time and then start accelerating the motor up to 60 hertz, and then it has another 5-second time at the full speed, and it starts to decelerate for another 15 seconds.
Cool. And then with this electric motor here, that's what this guy is right here. That is actually going to be spinning our hydraulic pump, which I got a circuit over here. As you can see, there's our electric motor. This ain't as detailed because it's a hydraulic circuit, not an electric circuit. There's our VFD telling our motor what to do, and this is our whole hydraulic circuit that the motor's going to be operating. Now we start, with our reservoir that holds our fluid. We're going to go up through our inlet strainer, which is normally just like a screen mesh, not real fine filter, but just something coarse to strain the fluid. This is a little bypass check valve. What that's for is if the strainer gets too clogged or whatever, you don't want to create a vacuum inside your hydraulic pump here, because that'll just cause cavitation, and it's all downhill from there. After that, we got our pressure relief valve to set our system pressure, and we have a dumping valve, unloading valve above that. What that does is, let's say our viscosity of our fluid is too thick because the temperature is too cold or whatever. So what we can do is we can just have the fluid going from the reservoir going up and then just dumping back into the reservoir, just to kind of create some heat, warm the fluid up, and get it ready to do some work. And then when we want it to do some work, we would just engage the solenoid here, which would shift this valve up, block the flow from going straight to the reservoir, and it would just continue on through the circuit, go through our pressure line filter, going up to our directional valve we got here, and we can direct the flow this way. Operate our bidirectional hydraulic motor, and then eventually go back through the return line filter up here and go back to the reservoir. This is our program, what we use to program the PLC to tell it what to do, and Garrett here is gonna run the whole
Let's change that to
the motor over there and show you how everything works, and he'll show you how the motor will excel for what time it's set to, and then be at a full 60 hertz here, and then it'll decel. So, alright Garrett, show me what's up.
So our start button is right here. Start button, stop, and our sensor. So I start the program to let the VFD know that it's okay to start when part is present. When part's present, it's going to start the motor in idle for 5 seconds and start ramping up, which it's doing now.
That don't even matter because you don't have program going on there, right? So we're on number 1. And number 2. And then take off these.
So now it's at its 60 hertz, which is at full speed. It's going to start ramping down now. It's going to continue this cycle until there is no part present, or until I press the stop button, which is going to DC inject the motor, which I will demonstrate when it ramps up again. So once it hits 60 hertz, I'm going to stop the motor with the DC injection. And when it DC injects, you shouldn't be able to move the motor. And when it stops DC injecting, you should be able to move the shaft freely.
And that's pretty much it. I hope you enjoyed the video. Have a good night.